Has China's new generation strategic nuclear submarine truly achieved a staggering diameter of 14 meters, thereby erasing the iconic humpback gap separating it from the world's most advanced underwater forces? In recent days, a claim circulating wildly among military enthusiasts and overseas think tanks has refocused attention on China's enigmatic underwater Great Wall. Allegedly, China's next-generation strategic missile submarine, likely the legendary Type 096, features a pressure hull diameter exceeding 14 meters. This figure is breathtaking not merely for its scale, but as a powerful signal. If true, it signifies China's strategic nuclear submarines will firmly establish themselves at the 20,000-ton displacement tier. Their massive hulls will easily accommodate longer-range, heavier submarine-launched ballistic missiles, eliminating the need for the humpback design once required to house missiles. This advancement brings China's tonnage and overall performance to levels rivaling the U.S.'s next-generation Columbia-class strategic nuclear submarines currently under construction. Is this merely bold speculation from online rumors, or the genuine prelude to China's deep-sea sword being unsheathed? Today, we delve into the mystery of the 14-meter diameter that has captured the imagination of many, and the evolutionary path of China's sea-based nuclear forces it represents. To grasp the disruptive significance of this 14-meter diameter, we must first retrace our steps and examine the hump imprint once etched upon the spine of China's nuclear submarines. For years, the humpback design has been a defining feature of China's strategic nuclear submarines, from the Type 092 to the Type 094, with its massive missile launch compartment protrusion ever present. This wasn't a design preference, but a necessity born of specific developmental constraints. At its core lay the inherent conflict between the submarine's pressure hull diameter and the length of its submarine-launched ballistic missiles, SLBMs. Previously constrained by core technologies like the strength of specialized steel and large-scale plate rolling processes, China's nuclear submarines could not achieve sufficiently large pressure hull diameters to accommodate the JL-2 missile with its strategic deterrence range. Engineers had no choice but to add an extra non-pressure hull section to the submarine's back, housing the missile within it, thus forming the turtleback. The first officially disclosed specifications of China's Type 094 strategic nuclear submarine reveal an underwater displacement of approximately 11,000 tons in a beam of 13 meters. Despite these substantial dimensions, the hump remains distinctly visible to accommodate the missile. While this design secured China's breakthrough in establishing a sea-based nuclear deterrent, achieving the strategic objective of first addressing the fundamental capability, its drawbacks are evident. It disrupts the submarine's streamlined hydrodynamic profile, generating additional turbulence and noise during submerged operations. Some analyses suggest this could significantly increase the submarine's acoustic signature, making it more vulnerable to detection by enemy anti-submarine networks. Thus, the hump has become a critical bottleneck in China's nuclear submarine technology that urgently requires overcoming. So, what is the key to overcoming this bottleneck? The answer lies in continuously increasing the diameter of the pressure hull. Only a sufficiently robust backbone can allow longer missiles to be fully housed within the pressure hull, thereby achieving a smooth submarine hull and fulfilling the fundamental objectives of noise reduction and enhanced overall performance. Reviewing the development of advanced strategic nuclear submarines worldwide reveals this as a common path. The U.S. Navy's current Ohio-class submarines measure approximately 12.8 meters in width with a submerged displacement of about 18,000 tons. Their successor, the Columbia-class, increases diameter to 13 meters and displacement to 20,000 tons. Russia's newest Boreai-class strategic nuclear submarines also reach a width of approximately 13.5 meters. Against this backdrop of benchmarking, the online rumors suggesting China's next-generation nuclear submarine will feature a 14-meter diameter appear truly earth-shattering. If this figure approaches reality, it would signify that the structural strength and dimensions of China's strategic nuclear submarines are not only catching up to but potentially surpassing the latest standards of the United States and Russia in certain dimensions. It suggests China has achieved systematic breakthroughs in top-tier submarine technologies, including ultra-high-strength specialty steel, giant section manufacturing, and precision welding. A 14-meter class pressure hull could fully accommodate the new generation of submarine-launched ballistic missiles, eliminating the need for a humpback design and delivering a transformative leap in stealth performance for China's nuclear submarines. Beyond shedding its turtle-like appearance, the 14-meter diameter hull will unlock a series of profound performance advantages. Foremost among these is the dramatic increase in missile capacity and strike power. The wider hull allows for larger missile silos and more efficient layout. The rumored Type 096 nuclear submarine may carry as many as 24 JL-3 submarine-launched intercontinental ballistic missiles. The JL-3 missile itself is believed to have undergone optimizations, including the use of new materials. Online estimates suggest its range could reach 12,000 to 14,000 kilometers, with the capability to carry multiple independently targetable reentry vehicles. This means that even when launched from fortified coastal waters near China, its firepower would be sufficient to cover major strategic targets worldwide, truly establishing a reliable and formidable underwater nuclear counterstrike capability. Second, the vast internal space enables the adoption of more advanced propulsion and stealth technologies. Analysts suggest the new generation nuclear submarine may incorporate cutting-edge technologies like shaftless pumpjet propulsion. Traditional shafted propulsion systems generate significant noise from rotating mechanical shafts, whereas shaftless pumpjet technology fundamentally eliminates this noise source. Combined with more efficient integrated natural circulation reactors, next-generation raft vibration damping, and anti-sonar tiles, this approach could reduce submarine underwater noise to levels approaching ocean background noise. As a result, China's strategic nuclear submarines will transform from their former role as underwater high ground into truly elusive deep-sea specters, with their survivability and deterrence capabilities increasing exponentially. Furthermore, the massive hull and complete elimination of the hump design will endow China's strategic nuclear submarines with a valuable strategic asset: strategic ambiguity. With the disappearance of the iconic large hump characteristic of ballistic missile submarines, their appearance will increasingly resemble that of attack submarines. For potential adversaries relying on optical satellites for space reconnaissance, patrol aircraft for aerial surveillance, and sonar arrays for maritime monitoring, discerning whether an occasionally surfaced Chinese nuclear submarine carries conventional weapons as an attack submarine, or serves as a strategic deterrent platform loaded with nuclear warheads will become exceedingly difficult. This uncertainty itself constitutes a potent deterrent. It compels adversaries to assess and respond to every scenario based on the worst-case possibility, significantly increasing the complexity and risk of their military decision-making while expanding China's strategic initiative. Of course, we must approach the 14-meter diameter claim with caution and rationality. To date, all details regarding the Type 096 nuclear submarine's specifications, including its precise diameter, displacement, payload capacity, and stealth level, originate from domestic and international analytical institutions, media reports, and online speculation, rather than official Chinese disclosures. The development of military equipment, especially strategic nuclear submarines as national strategic assets, routinely operates under strict secrecy. Online information is complex and varied, encompassing both reasonable inferences based on scattered data and potentially exaggerated or speculative elements. For instance, claims that the submarine's noise level has been reduced to below 95 decibels pertain to an extremely specialized and sensitive field, making its actual performance difficult for outsiders to verify. Therefore, the 14-meter figure is more symbolic, a milestone signifying that China's nuclear submarine technology may have entered a new phase, rather than a precise number requiring meticulous scrutiny.